In this video, we're going to investigate the relationship between secant lines and tangent lines to try to understand what the derivative at a point and also the derivative function should look like. For this function, I have set up f of x equals 6 plus 3x minus x squared. You are free to change this at any point, and I'll put the link for this Desmos file in the video description. The point we're going to consider is the point here, point 36. You can toggle this point on and off by clicking the folder icon right there. The idea is pretty simple. Most students have at least an intuitive understanding that there should be something called a tangent line, shown here. And the computer tells us the slope of that line is -3. The question is, how can we understand why it's -3? As should have become clear in section 2.1, the idea of instantaneous rate or instantaneous velocity is actually very awkward. It's difficult to discuss how fast something is moving if we're talking about only a single point in time. So tangent lines are awkward to talk about, but secant lines are quite easy. A secant line is simply connecting 2 points on the graph. So we have 2 points on the blue graph here, the green point and the red point. The red point down here is simply labeled the slope is. The slope is of the purple line now, which is of the secant line. You notice it is different than the idea of the tangent line. The tangent line touches the graph only, in this case, at the green point, where the secant line touches both at the green point and the red point. You notice the two slopes are fairly close. The idea, pretty simply, is if I take the secant line and change how close it is, notice that the value of the red slope changes while the value of the orange slope does not. That as I get closer and closer to the green dot, the value of the red slope gets really close to 3. And in fact, if I cross over exactly at 3, it is undefined because the green point and the red point are now a single point, and we can't talk about the slope at a single point. If I continue to drag off, oops, sorry about that. Let me fix that. One little quick thing here. Sorry about that. If I drag past the green point, you'll notice that at this point, the slope is less than -3. And at this point, the slope is bigger than -3. So the idea, I think, pretty clear is if you took the limit from the left-hand side, the limit of the red slopes does approach 3. If I look at the limit from the right side, the limit of the red slopes also approaches -3. So it's very sensible to talk about the limit of the purple lines approaching the orange line. More appropriately, what we would say is that we fix the green point and look to define the orange line to have the point at the green point and the slope of the limits of the slopes of the red. So I take the red point and drag it closer and closer to the green point. Whatever slope it approaches in a limit is the slope of the orange line. Since this is calculus, you want to zoom in quite a bit. You can get this very, very close. The whole point here is I can get as close as you want me to get to. 3.001. I think I can get even closer than that if I go a little more zoomed in. All right, so as I zoom in further and further, I can get the red value to approach the orange value even more closely. Now, once we've done that, we zoom out a little bit. Let me first pull the red dot away. The idea in section 2.3 is to simply try to create a function out of this. So if I now turn on this indicator, then what this black dot is, the value of that, I can actually turn that on. Sorry. Label. I think I have this up to do this correctly. Give me 1 second. This is simply the point. X is the same as the A value here, and the output is this value here. If I take the green point and drag it, notice I always have the A value as well as the slope of the orange point at the A value. I can turn off the secant lines for now. We understand that to create the orange line, we use the purple line. So now we simply understand we can create an orange line at every point. And now, for every point, I simply look at the slope of this line. So I take the A and the slope of the tangent line to create this dot here. And as I drag the green point, I create a new function because every green point gives me a black point. Connecting all the black point gives me a new function, and this is the idea of the derivative function.